Welcome to problem 5.55a. This is a problem involving the grams to moles, moles to grams, our stoichiometry. It is from section 5.7 in your textbook, Math Calculations for Reactions. Okay, so we have ammonia and oxygen react to form nitrogen and water. So we have our balanced equation here given to us. And as always, we're going to first write what we know, right? So it asks for how many grams of oxygen are needed to react with 13.6 grams of ammonia. Oh, and if you hear Elvis music in the background, the college is doing a test over the intercom, so I apologize if you don't like Elvis, but you guys may not be able to hear it, I'm not sure. But, okay, so here we've got what we're starting with. Okay, so we always write this out first. And we know if we have grams of ammonia, and we don't just have grams, we have grams of ammonia. You want to be sure you include the compounds in your unit. And since we have grams of ammonia up top, we're going to have grams of ammonia on the bottom here to cancel out. Okay, the first thing that we do is we're going all the way from grams to moles of oxygen to grams of oxygen. So we're converting from one compound, the mass, to a totally different compound. So we know that we have to use our balanced equation. Okay, so the first thing we do is we add up the molar mass of ammonia. So if you do this, you should get, so you add up nitrogen, which is 14. So this is where we look at our periodic table. Okay, it should be 14. Then hydrogen's about, 1.01 or so. All right, so we're going to get about 17 when we add up the molar mass. Okay, and every time we go to the periodic table to find the molar mass, this is always based off of 1 mole. So our units can cancel. Okay, so we know our next step, we're going to have moles of ammonia on the bottom. Okay, this is our main key step where we have to use the coefficients in our balanced equation. It looks like we have, so if we look at our unit factors here, we've got for every 4 moles of ammonia, we have 3 moles of oxygen. So this is the mole-to-mole ratio that we're concerned with because we're starting with ammonia and we're wanting to find the grams of oxygen. Okay, so we can flip this over. Either way, work. Okay, so we're going to flip it over so that our moles is in the denominator so that our moles can cancel. So we have 4 moles of ammonia for every 3 moles of oxygen. Okay, so if the problem had just asked for moles of oxygen, then we could stop. Okay, but we have to go one more step. Now we just have to go from moles of oxygen to grams of oxygen. So we know in 1 mole of oxygen, of O2, we have 32 grams. Okay, so we're just finding the molar mass. So oxygen is 16 on the periodic table, and we have 2 of them, and so that gives us 32. So now our moles will cancel. Okay, so we do this in this organized fashion so that our units will cancel so that you don't accidentally, flip-flop your numerator and your denominator. Okay, so if we multiply everything on top, multiply everything on the bottom, and then divide, we get 2.23 excuse me, looking at a different problem. Second, you should not get 2.23. Okay, so if we take 13.6 times 3 times 32 divided by 17 times 4, we should get about 19.2 grams of oxygen. I hope this helps while you're working your mastering homework.